Okay, in today's video, we're going to be doing number 35 in LeetCode search insert position. So given a sorted array of distinct integers, meaning each element inside the array is going to be a different value and a target value. So we're going to be given the target value and this numbers array. Return the index if the target is found. So in this example, you could see the target is 5. 5 is found inside of nums. We return 2 because 5 is at the 2 position. 0 position, 1 position, 2 position. If not, return the index where it would be if it were inserted in order. You must write an algorithm with O of log n runtime complexity. Now, if you look at the constraints down here, you're going to see that the length of the array is going to be anywhere from 1 to 10,000 elements, and each element inside the array, so each individual element, is going to be anywhere from negative 10,000 to 10,000. Nums contains distinct values sorted in ascending order, so that means that there's going to be no repeats. It's going to be sorted from lowest to highest, and the target number is going to be anywhere from negative 10,000 to 10,000, same as each element. Now, the thing that's a little bit trickier about this one, even though it's an easy, is that it must be O of log n. And what it means by this is, let's go ahead and pull this open. So let's say I have an array, and I'm going to go ahead and just create a longer one here. Okay. All right. So this array here is 4, 8, 12. I'll add 4 more just for simplicity. So we have 16 characters here. Now, if I had an O of n solution, I am going over these elements one by one. So an O of n solution means I'm actually stopping on each one of these, and that would be just a for loop incrementing I1 with each iteration of the loop. So if I wanted to have an O of n solution, I'd have something that looks like this. And now we'd go over it one by one. But I need O of log n. And what that means is if we have 16 elements in this array, then we should never have to perform n operations. N operations would be 16 operations. Log n means that with each iteration of our loop, we're going to cut this in half. So, boom, 1, 2, 3, 4. So you could see that if we have 16 elements, we never want to have more than 4 operations before we find the 1. And you're going to see a pattern here. So if we have the 3 to the second power, 4 to the second power, and so, here we go, my bad. 2 to the second power is 4, 2 to the third power is 8, 2 to the fourth power is 16, 2 to the fifth power equals 32. And so you could see that this is our log n here. So if we have 4 elements, we should never need more than 2 operations. If we have 8 elements, we should never need more than 3 operations. 16 elements, we should never need more than 4 operations. Because with this, we're cutting it in half with each operation of the loop. And we're not actually going to use a for loop. We're going to use a while loop in this one, and we're going to use binary search. So let me show you how that's going to be done. And I could actually show you on the array that I had before. So if we have this array here, we're going to have a left pointer. We are going to have a right pointer. And we are going to have a mid, or just M pointer for now. And what we're going to do, since we know this is sorted, is we're going to take the value of R, which in this case, if we have 16 elements, the value of R is going to be 15. The value of L is going to start as 0. And we're going to get the value of M by running this operation here. So left plus math.floor, right minus left, divided by 2. I believe this is the correct one right here. So we're going to take 15 minus L, which is 0. So 15 divided by 2. 15 divided by 2 is 7.5. Math floor is 7 plus L, which is 0. So we're going to be 0, 1, 2, 3, 4, 5, 6, 7. M is right here. M is equal to 7. And so M is pointing to this right here. Then we're going to test this. We're going to say, let's say our target for this problem here is 2. So we're going to test this. Is nums M equal to our target? No. Nums M is equal to 10. Our target is 2. So we know that's not incorrect. Then we'll check. Is nums M greater than our target? It is greater than our target. So in that case, we move R to M minus 1. So we basically just cut all that right there. So now we're left with this here. And to show you that we're not using any of this anymore, I'll leave it right there just because we still have M at that position. And the array is still there. It's in place, but I'm just doing this to make it look a little bit easier. So now we do the same thing again. We know that it's less than, so we're going to do R minus L. So R is now equal to M minus 1, which is 6. So we do 6 minus 0 divided by 2, which is 3, plus L, which is 0. And that is going to be M equals 3. So now we test again. Nums M, is it equal to our target? No. If it was, we would just return M. Is it greater than our target? Yes, it is greater than our target. And so what we do is we move R to M minus 1, so one position before. And then, like I said, this array is still there, but see how we just cut it in half again? So that's 2 full operations here, or 2 full iterations. Now we do the same thing again, R minus L. So we're actually in the 3 position now, or 2 position now. M is in the 3 position, L is in the 0 position. So 2 minus L, which is 2 minus 0 divided by 2, 1, plus L, which is 0, so 1. So now we are in the 1 position, or mid is in the 1 position. There we go. Now we test again. Is this equal to target? Nums M. No, it's not. Is nums m greater than target? Yes. So we move r to m minus 1. So now it's in the 0 position. Now we know that R and L are at the same spot, and we don't want to break out of the loop yet because we haven't found our target, or how are we going to know when we need to break out? So basically we're going to do this one more time. We want it to execute again, and so because at the end we're just going to return L, and so and the reason why we're still going to run it when R reaches all the way to the left side is because we still need to check this. If R moved its way all the way here and we just had to check for while left is less than right, and now that they're in the same position, they're both in the 0 position, we break out of the loop, we never have a chance to test this one, and so we never know if this target is not in the array where we're going to place it. So R minus L, 0 divided by 2, 0 plus 0, mid moves to 0, is nums m equal to target? No. Is nums m greater than target? No. Is it less than target? Yes. So in this case, we increment L by 1. Now we're at the point where L is not less than or equal to R. It's 1. And this is where we're going to return. Now we break out of the while loop because L passed R. L is 1, and we return L. So let's go ahead and do some pseudocode for this problem here. So we are going to create our variables, left and right. We're going to, let's just say, use binary search until left is on the right of right. Find the mid element, test mid element to see if it's equal to target. If it is, return mid. Otherwise, test mid to see if it's greater than our target. If it is, move right pointer to mid minus 1. If it's not greater than, then we know that it's less than. So test mid to see if it's less than our target. If it is, move left pointer to mid plus 1. And then if ever we come to the point where left moves to the right side of our right variable, we just break out and we return left. If there is a case where left is the one that moves all the way to the end of the array and left ends up moving past, we know that the target was not in the array and the element we want to include in the array. Let's just say we have this 0, 1, 2, 3. Now L equals 4. We know that we want to enter the target, insert it at the 4th element, so at the end of the array. So that is that. Go ahead and type the code. So we need let left equals 0, let right equals nums dot length minus 1, while left is less than or equal to right. Do all this. let mid equals left plus math dot floor right minus left divided by 2 if nums mid equals our target, return mid. If nums mid is greater than our target, then right equals mid minus 1. If nums mid is less than our target, then we know left equals mid plus 1. We're just sliding it up. And so inside of here, we're either going to find our target or not find our target. If we find our target, we know that our mid has landed on the target because nums mid equals target. If we don't find our target, eventually left is going to be at the point where either it has passed right and it has moved to the right side of the right variable. And in that case, we are going to break out of this while loop and we're just going to return left because whatever position left is the index that we need to add it. So let's go ahead and test this. 2, 1, 4. Let's see what they're expecting. 2, 1, 4. Let's go ahead. Paste the code. This looks good though. See what we got. Test this out. Passed. Passed. There we go. And that's an O of log n solution right there. If anyone has any questions or ways to improve this solution, feel free to just leave them in the comments. Or if anyone has any questions, clarification, just don't quite understand it, let me know exactly what you don't understand. I'll do my best to help you understand. And yeah, we'll go from there.